So our speaker tonight is Slava Kim, one of the core developers here at Meteor. I know a lot of you know Slava online. He's super active in the community. We really love him for that. Here at Meteor, Slava was a big part of the Windows support that we just released with 1.1. He's also done a lot of work on mobile, Mongo uplog tailing, and Blaze features. He has a really interesting talk prepared for you today that I think will really teach you a lot about the fundamentals of how Meteor works. Specifically, what does it mean to be a real-time database, and what functionality has to exist for a database to integrate with a modern application architecture like it does in Meteor. So everyone, let's welcome Slava.
I'll just prepare my notes. Hey, everyone. So today's talk is going to be a little bit educational. It's not going to be very exciting with announcements and all of that, but I still think you'll benefit from it just by learning how Meteor architecture was designed and how it works in general and what does this modern web application architecture expects from the data store that you might use. And I think this talk is not really specific to Meteor. It's just an explanation how Meteor does it, but you can as well implement it in your own stack if you want to. So the talk is called, what does it mean to be a real-time database? And I guess the answer is obvious, like it needs to be a database, it stores data, and it should be real-time, it should give me notifications. But we'll look into more details, how Meteor uses different databases or might use, and why it is so important. So as you know, Meteor is an SDK that contains a lot of different functionality and features. And this picture, I've been using this picture in many, many slide decks. The basic architecture is you have a server side with an access to the database, and somehow you see the changes there. Also on the client side, you have a cache. In our case, it's mini Mongo, but it could be something else. And this cache is driving all the UI changes on the client. And between them, there is something called DDP. It's a protocol that defines how do you pass data around and how do you perform any actions from the client on the server. So Meteor is really a collection of packages and technologies, and it's not uncommon to see for us, like other people in the internet, take apart different parts and use it in their applications. Also, you can replace different parts. For example, Mongo could be replaced with some other database, and Blaze can be easily replaced with React or Angular, as you might have seen before. But there's something very core to Meteor that it's not really easy to replace, and actually you shouldn't, because it's in the core of the functionality of Meteor. And I'm talking about the protocol, DDP, and everything is just structured around it. So DDP is a protocol, is just a definition how data should be passed around and how calls, method calls should be performed from client to server. So it's not a magical implementation, but it's just in design how the architecture should look like. And particularly, it helps us to implement this important feature called optimistic UI. So you might have heard other names. In Meteor here, we often use client-side prediction or latency compensation. Also, there are other names like death reckoning. It's used in gaming to predict where your character will appear on the screen, even if you don't have enough time to communicate with your server. Like the simplest definition that I found was speculative mutations. The basic idea is when you modify something in your database, first you do it on the client so the UI can update immediately, and only then you go to the server and do it in the background. So for the user, when they use your application, everything appears to be really fast because all the changes are made locally. But also, the changes are validated on the server. So if the client tries to do something sneaky, the server will invalidate all the operations and say, look, here's what actually it should be, and don't try to speculate too much. So this is a core feature of Meteor that I don't think we talked about enough. But it actually lies in the core of Meteor. So here they have an example of latency compensation in the application called WhatsApp. So it's a chat app owned by Facebook. And in this video, you can see the user is typing some message, hitting submit, and you can see there's a small clock that says it's not sent yet, and then it becomes a tick, meaning that it was sent and acknowledged by the server. So here's a perfect example how latency compensation works. We insert the message immediately into the chat history, even though it didn't hit the server yet, and only then we update it to a tick. So I'll just show one more time. It becomes a tick after a second. So here's another example. It's a Hackpad. It's a collaborative web app to collaborate on documents. And as you can see on the right side, I'm typing text, and it appears on the left side much slower with some latency, because I'm doing it over the internet. So on the right side, I can type letters. Everything works just like a local text editor. But on the left side, it actually appears with a delay. And this is another example how you can just perceive latency in a different way. For the user of Hackpad, they don't even know which letter was synchronized, which was not. So if it was done in a traditional web way, I would wait for every letter to be synchronized with the server, and I would need to wait before I type any next letter, which would be ridiculous for a text editor. So latency compensation is a complex topic that tries to help you achieve good user experience. And recently, we have released a blog post. One of my coworkers called Sashko Stubailo wrote a blog post on our Meteor blog. And he has a written down explanation how it works with diagrams, and you can see it online if you want to later. So today, I'm going to focus on how you would implement that, or like how it is implemented in Meteor. And my claim is it is really hard to implement yourself without a very well thought out architecture that Meteor already provides. And just as an example, I want to show you the website called Instagram.com. I don't know, maybe you know it. But they have a web version of it where you can see pictures and comments. And I just want to show you how latency compensation can break even in a very successful web app. So let me type some comment here. I'll press Enter. It will appear and disappear. I don't know why it happens, but if I refresh the page, I see it's still here. So let's try again. I'll type some comment, press Enter. It disappears. I don't know why. I think it's a bug, but that's just a demo for you guys. It is hard. It can be hard. And Meteor tries to make it easier. So again, here's a general architecture. It's exactly the same picture. And I want to walk you through how a client would make a modification to the database from the browser to the server and back. So imagine we're building a chat app just like WhatsApp, because everyone knows chat apps are the most valuable apps out there. It's not Instagram anymore. But if you can see how it usually happens. Usually, it starts with a user action. And here, actually, we're focusing on the data layer. That's why I will dim out the front-end part, because it can be anything else. So it starts with the front-end layer getting a user interaction. A typical user interaction would be pressing a button like submit this message or like create this chat message. This code runs a JavaScript function that would be executed in Meteor on both client and server. This is what we call RPC, remote procedure call. And in Meteor, RPCs are simulated on the client to achieve this latency compensation, this fast result. So on the bottom right, I have an example, a pseudocode, how my RPC would look like. It would be something like, oh, if it is in the simulation, then add a message and set a flag called is in flight to true. Otherwise, on the server or not inside the simulation, just add a message. So here, I set a special flag in flight, and I do it for a specific reason. I want to distinguish documents that have been synced already with the database and documents that have not been synced. So remember that clock in WhatsApp? That's what I'm doing. I'm trying to check if I should show a clock or a tick mark. So I press the button, I run the RPC on the client and on the server. What happens next? The client is changed immediately. It's driving the updates in the UI. So the simulated changes appear immediately. So later, after 300 milliseconds on my server in Arizona, I will get the result propagated to the database. So it will be in the real database, and my database will emit a notification, hey, this document has changed. So Meteor server would notice it and propagate this update to the client over DDP from the server. So you can see the propagate updates. And after it propagated all the updates, it will send me a special message in DDP called update, or updated. I think there is a typo here. But the general idea is the message updated means, hey, look, client, you've done some changes in RPC, and I already propagated all the changes in the database to you. So you can be sure that the state I'm presenting you is exactly what it should be after the RPC is done. So the client understands that it synchronized the state with the server, and it can throw away all the simulations that it have done before. So what will happen, it will have a tick mark first, and then it will receive this message that says everything is ready, and it can throw away this tick mark, saying that, OK, I synchronized everything. I don't need to keep it around anymore. And then you show the actual change. So this is the basic idea. And this whole idea is possible because the protocol of communication between client and server supports it. So we have a DDP spec on GitHub, and it's just a definition what each message type means. And there's an interesting thing in DDP. It combines the relationship between data notification, or like notifications about data synchronization, and remote procedure calls. Something that you wouldn't normally mix together, but in this case, it makes total sense because we need this updated message. So later in the spec, you can see there's something about updated. It goes from server to client. And what it means like I propagated all the changes in data sync related to your method call. So this is powerful, and we'll just look how it's implemented in MongoDB, with MongoDB right now in Meteor, and how it could be implemented with other databases like ResynCDB and PostgreSQL. So let's start with MongoDB. You probably have heard it many times. Meteor tails oplog. Oplog is a replication log of MongoDB. This is how databases replicate themselves in case of failure. And what Meteor does, it connects to MongoDB and looks at this endless stream of documents of changes. So every document that represents a change contains an ID, what document is changed, what fields are changed, but also it contains a timestamp. So every change is ordered. And at any given point of time, we can just figure out what is the latest timestamp in the oplog, in the replication log. And this is what helps us to actually understand when we can send this updated event to the client. So what happens, we start in RPC. As soon as every write is done, we try to remember the position in oplog. And then when our observers actually reach that position, we say, OK, we are sure that everything related to this RPC is already propagated to observers. And this is how it's implemented. And yeah, oplog is good because it has changes and timestamps. And now let's look at a different database. It's a database called ResynCDB. What ResynCDB is an open source database that works on documents. Similar to MongoDB, it doesn't have any transactions or joins. It has joins, actually. But it also lacks some other features like replication, which is really important for a database. I think this is why it didn't get much adoption yet. But what happened, we had a hack week here in Meteor. And hack week is a time when every core developer takes a week of time to implement any hacks they want. And it doesn't have to be the highest quality, but this is some experimentation time for us. So what happened, I decided to build an integration with ResynCDB and Meteor, just because I have heard that ResynCDB is advertising itself as a database for real-time web. And the reason they do that is they have implemented something called change feeds. And change feeds is essentially the notification stream for queries. When some query changes, like it just gives you an event, hey, this document changed for this query. So this was useful, and I thought, OK, let me implement it in my 1 week. And I got the proof of concept working with a demo. And I put it on GitHub. And even though it's not ready for production, people tried to use it and kind of failed. But I think I say it, I tell it very clearly in the README, it's not for production use yet. And I'll explain why. So what works with ResyncDB? By the end of my week, I figured out that queries, pops up, RPCs, all of that works. For the client-side cache, I used a repo called Equalite, which is a re-implementation of ResyncDB query in JavaScript. And I got all the client-side simulations working. So what didn't work really was latency compensation, the most important part of Meteor. And the reason for that is ResyncDB doesn't expose additional metadata. So remember oplog? We had timestamps. Like every change could be associated with some unique identifier. In ResyncDB, it doesn't happen anymore. Like every change just appears in the stream, and you can never know if your change has been propagated all the way through. So this is why I couldn't get the latency compensation to work, that magical updated message. Also, another thing that I found about ResyncDB, it doesn't support change feeds for complex queries like joins. Also, it doesn't support initial result set for most of the queries except for sorted queries. And Equalite. Unfortunately, I found out that this repo was created in the free time of its author, so it wasn't really the level of quality of mini-mongo that you would expect, like many queries will fail or there are typos in the source code. But I'm pretty sure it will improve in the future. And once ResyncDB exposes more metadata about their changes, it will be much, much easier to implement the support. So what about PostgreSQL, you might ask? So I've done some research. It's not written in code. It's not even written in design yet. But I found out that replication log in PostgreSQL is the same format as write-ahead logs that all the databases use for recovering from failures. Also, PostgreSQL provides a lot of useful functions to actually look inside of replication log and get all the positions and locations and identifiers, something that ResyncDB doesn't have, but we got from MongoDB oplog. So this is just an example like how one database, ResyncDB in this case, implements notifications, but they don't implement this additional metadata that Meteor might need. And PostgreSQL is the opposite. It doesn't implement the notifications. I mean, there are other ways to do that, but it actually is a very mature database, and it provides a lot of different functionality for all sorts of needs, including querying the replication log. So what is real-time database really? So if we skip the first 3 bullet points that it doesn't lose your data, like you can query your data, you get the notification with initial set results, and in the end of the day, you actually get the metadata with your revision numbers, because this is something you need to implement more complex features on top of real-time notifications. Just real-time notifications would not be enough in an architecture like Meteor, and I believe many other modern architectures where you would have latency compensation built in, and there would be one source of data, one source of truth, and everything would be working from one database, or like from one source. So this is it. This is my last slide. I hope you learned something about Meteor and how it works inside. And this was my small project in 1 week about ResyncDB and a small research how it would be done in other databases. Thank you.
Right. Does anyone have a question for Slava? Rahul.
So looking at the last slide,
yeah.
You said skip the first 3 bullet points. The last bullet point to skip basically describes that there is a real-time database in existence that fulfills all of the requirements, but requires you to write your queries in Erlang.
Oh, I can explain. So I tried to make a joke. In the third bullet point, I tried to make a joke about one database that at some point of time required you to write queries in Erlang. But I don't think it does anymore. And I think it was just a big stone on adoption for the database. And no, it doesn't have any real-time features like notifications.
I was excited.
It's good to have a dream.
More questions? Yeah, in the back.
Do you
know if Rethink is planning on adding support for different types of queries change feeds?
The question was, do I know if RethinkDB have any plans for change feeds for other types of queries? So my understanding is something like join is just hard to implement incrementally for notification feeds, and I don't know if they have any plans for that. What I do know is they plan to include the initial result sets for more queries that they support. This is something that is not supported right now, and it's hard to deal with in the application layer because you don't have any control over concurrency there. So they want to do that in the next version, 2.1. And I asked them about more metadata, about the revision numbers on the changes, and they said that they might consider that if enough people will ask for it on their GitHub tracker. So if you guys want, you can try and ask them, providing a use case, of course. But yeah, even if they don't, I think at some point, a lot of database will expose most things like this because the use cases will require more and more control over what's going on inside.
We have a question from Eric Wine online. So he asks, do you plan on continuing to develop RethinkDB for Meteor?
So the question is, like, do I even plan to support it at all? And again, I'll repeat it. I developed it in my time dedicated to hacks, and I have a proof of concept working. And until every blocker is resolved, I'll just not be able to provide high quality support for that. So I will wait for a magical Christmas or Hanukkah when I get all the features I requested from RethinkDB team. And then I'll be more than happy to spend my Christmas holidays implementing it.
More questions from the room?
Thank you.
All right, thank you.